Okay. Okay. Radian and degree conversion. Okay. So to find the radian from the degree here, pi 1/80 multiply degree. Okay. This is sometimes the unit LAD. The degree unit is the degree here. Okay. And sometimes if we wanted to find the degree here, we have to was conversion 180 divided pi multiply radian. Okay. So to find and analyze the sinusoidal waveform, so we needed to about the concept and should have a capability to make conversions between radians and degree. Okay. So next one is the angular velocity. The angular velocity. Okay. Okay. The definition is the velocity with the radius vector rotate about the center, called the angular velocity. Okay. Actually, they can be determined from the following formula. So the angular velocity, actually there's maybe omega here, is usually, there's the physics, the distance divided the time velocity, right? Time, the distance here. So for this here, the distance sometime degree or sometime the radian. Okay. And then the time is the second. Okay. Sometime we're gonna SEC. Okay. So that is, we can also the angular velocity, the omega, the alpha, the divided, the t, or sometime the delta t. Maybe again, the alpha is sometime degree or the radian, pi to pi, so on. That is the 180 degree, 360 degrees, so on. Okay. All right. So the next one is alternating the waveform. Okay. The alternating the waveform. So alternating waveform is a kind of the periodic waveform. That is very important, the concept. Okay. The periodic the waveform here. So what is the periodic waveform? That is the waveform that continually repeats itself after same time interval. Okay, so that is very important. The concept same time interval is, we're going to call it sometimes cycle or period. Okay, so that was, we're going to writing the T, large T here. Okay, so sinusoidal waveform like this one here. This is the waveform here. If they have this a T time here, that is the V, the amplitude. So the peak voltage to the 0, usually that is the 9 degree, or sometimes the radian, the pi over 2 here, that we're gonna call as the peak voltage. Okay. And then the red one, oops, right there. And like this one, can you see that the peak to peak value that was, we're gonna call as the peak to peak voltage. Okay, the peak to peak voltage. So that was 2 times boost to the peak voltage like this one. Okay, and then from this graph, one period that we're gonna call as the cycle, sometime the period. Okay, and then the T, the period, is the equal to 1 over F, like this one here. Okay, and from maybe the previous definitions for the periodic waveform, that has the one very important characteristic here, continuously repeat itself. Okay, so that means that one is a sinusoidal, right? But sometimes it make rectangular, sometime it might be able to the triangular. Okay, it depends, but they should be had the same, like this one, same pattern. Okay, all right, that is very important. Okay, so and then we're gonna learn about the RMS value. Okay, especially for voltage, RMS. So the RMS voltage finally is a peak voltage divided root 2. The RMS mean root mean square. Okay, root mean square. Okay, so that means 1 over root 2, 0.707. So that means that V sub RMS for the sinusoidal waveform, that should be for sinusoidal waveform. Okay, so V sub RMS is 0.707 and V sub P. Okay, because right there, here. So it depends on the type of the waveform. We have different the RMS value. For example, sinusoidal, the waveform is with a P and root 2, okay? But the rectangular waveform is with a P, means with of RMS, okay? That's very important, okay? And then the last one is triangular waveform is with of RMS is root 3 over the V sub P, okay? You know, but sometimes the waveform not maybe adding to the DC voltage. For example, that is the 2 voltage, the plus sinusoidal waveform like this one, for example, 1 voltage minus 1 voltage. Okay, so that one is what? That is the DC voltage. That is maybe AC voltage. So for this case, we can draw 2 voltage, right? Like this one. So that one 3 volt. Oops, just right there. That one is like the 1 voltage here, okay? So for this case, for AC plus DC, for this case, V sub RMS is V sub DC square plus V sub RMS square. Okay, so V sub RMS means it depends on the type. You know, sometimes sinusoidal waveform, sometimes rectangular, sometimes it depends on triangular waveform. You know, we can calculate it. Okay. All right. Any questions? Okay. All right.